In this video, we will discuss Earth Leakage Protection System for Power Transformer. From the construction, you can see three phase lines of primary winding of a power transformer are taken through the core of a current transformer. So this is R phase, this is Y phase, and this is B phase. So these three phase lines of primary winding are taken through the core of a current transformer. This is the core of a current transformer. This current transformer carries a secondary winding. The operating coil of a relay is connected to this secondary winding. Now, earth leakage fault in a power transformer happens when there is some insulation breakdown in the winding, and the value of this earth leakage fault current is very small compared to the current due to short circuit fault. Now, under normal operating condition, when there is no winding is grounded or earth, or you can say leakage free system, the vector sum of three phase currents, let's say for R phase current is IR, for Y phase current is IY, and for B phase current is IB. So vector sum of three phase currents is equal to 0 under normal operating condition, which means there is no resultant current. If the vector sum of these three phase currents is 0, this means the vector sum of three fluxes for three phases will be 0. There will be no resultant flux which is supposed to flow in the core of a current transformer. Since there is no resultant flux, this means no flux links with this secondary winding of CD. Since there is no flux links with this secondary winding of CD, there is no current flowing through this relay. If there is no current flowing through this relay, this means the relay is not activated. So, under normal operating condition, since the resultant current is 0 for three phase currents, therefore the relay, which is earth leakage relay, this relay will not be activated under normal operating condition. Now, what happens during an earth leakage fault? Let's say this winding is grounded or earth, then the vector sum of three phase currents is no longer 0, as this resultant current will flow through the neutral and returns back. As the vector sum of three phase currents is not 0, then there will be some resultant current, and this resultant current shares flux in the core. So resultant current shares flux in the core. So due to this flux in the core of the current transformer, EMF will be induced in the secondary winding, and due to this induced EMF in the secondary winding, current flows through the relay, right? Now this resultant current which flows through the relay, compare the value of the predefined fault current. Normally 20% current setting is used for this earth leakage relay, as the leakage current is very small, therefore 20% current setting is used. When the value of this leakage current exceeds the predefined fault current level, then the relay operates, and this is how the relay coil is energized in an earth leakage protection system in a current transformer. Then this relay trips the circuit breaker and disconnect the faulty transformer from the system. Now you have already know that this earth leakage protection relay works if the sum of the three phase currents is not equal to 0. If the sum of three phase currents is equal to 0, then this earth leakage protection relay will not activate. For this reason, in case of line-to-line fault, when the fault is associated within the three phases only, there is no associated of grounding. So in case of line-to-line fault, we know the sum of the three-phase current is equal to 0. For this reason, this earth leakage protection relay cannot detect the line-to-line fault. And for detecting line-to-line fault as well as earth leakage fault through a combined system, a combined earth leakage protection and face-to-face protection system is introduced. We will discuss this in the next lecture.